Hi, I'm Timo Harbo and I run the course Python for Structural Engineers. In this video, we'll look at how we can work with XML files. A lot of finite element analysis packages allows you to input your finite element model as an XML file. And that means you can define a full finite element model in a text file, which also means you can do all sorts of edits and changes by just editing this text file. And if you can work effectively with these XML files using Python, you can quickly do various iterations of your models, do sensitivity analysis, and it just gives you a large level of control to the input to your finite element models. So let's dive into it. So you can see here that an XML file is essentially just a text file. And what it consists of is opening tags and ending tags. Let's go straight into the middle of the code somewhere. Let's go here. So here you see we have opening tag, where we say we have a curve that starts here. And then down here you have this backslash, with saying exactly the same thing, meaning that now whatever we wanted to say about that curve ends. And everything that's in here, you can see it by the indentation, belongs to this curve. We start a curve, and this curve has some attributes, which are written in the same line. And in this case, it's a line. And then it has some objects inside, which is a point and a point. And each point has an attribute, X, Y, and Z. Now we can also go a step outwards. We can go all the way out here. You can see we have a structural bar. It has a name. It's a type column. It has a GUID. And inside this bar, we have all these things here. We have a curve, we have some connectivity information, eccentricity information, essentially all information that relates to this structural element. This is not a very nice way of looking at an XML file. Let's have a look at an online XML viewer. If you just go to Google and search for XML viewer, you're going to find a lot of different ones. Let's just take the first one here. So now I've copied our entire text file in here and I press XML viewer. And now you can start investigating this file here. Database, you have some entities, you have some bars. And here's actually the one we looked at before, where you have the curve in here that has 2 points, that has X, Y, and Z coordinates. In short, an XML file is essentially just a nested data structure full of objects. Let's look at how we can work with this kind of file format in Python. So the first thing we want to do is, of course, to load the file in. We run this script here, put the file name in, and we see if we can find it. And we see down here that the file path that we have put in exists and the file has been found. Now we have used the OS module earlier, but we don't really want to start reading this text file here line by line. There is a Python library which can help us read it in a much smarter way. It's a package called XML, and what we want to do is we want to get into XML, e3.element tree, and we want to import it as et. And then we want to pass the file. So we get in here, and now we have loaded the file in. And we have saved it in this tree variable. And you can really think about this as a tree. You have the root down here, and you can go further and further out into the branches of this tree until you reach the leaves out at the end. So let us start at the root of the tree. We say get root. And let's see what information we can get out about the root of this tree. We find the tag and we find the attributes of the root. So the tag we get out from the root of the tree, you see down here is database. Let's go in and look at our XML file in here. We have the root here, tag is database. And then we also have all the attributes down here. And you can see when we print those, we get them here. So that's our tag and attributes. And then we also have the children of this database. And the children are these objects that we have here. And now we can do a loop. We can go through all the children of the root and we print the tag and their attributes. So you see here we get entities, sections, material, and so on. And none of them have any attributes. Then there's also the find function. If we want to get a specific child, let's say we want to get entities, and we just save that as a variable entities. And as we just saw before, it doesn't have any attributes. So when you try to print the attributes of entities, you get nothing. So now let's see if we can go from database, entities, into bar, and then get all the way down to these points. So we know the end coordinates of this bar. So we need to get the child until we get the attributes of this bottom object here. So first we go in, then we go into the bar and we find the bar part, we find the curve, and we find the point. Let's have a look at that. You can see first we get the attributes of the bar. You have the name and type here. You get the attributes of the part, of the curve, and down here you get one of the endpoints. We may actually want to find all the endpoints, and for that we can use the findAll function. So we go into curve and we find all points. And now if we print the attributes, we get both point 0 and point 1. So we have the start and end point. And then we can use the get function to get out the coordinate of the first point. So this is how we can access data in an XML file. But really interesting here is if we can start writing XML. Let's start by doing a super simple change. Let's just change a coordinate of one of these endpoints. Go in, we find all points. We get the second point here. We get the C coordinate, and we're going to change its value to 1. So let's try that here. You can see that C coordinate is modified from 0 to 1. And one important thing to notice here is that we only use strings. So you don't want to do this because that's an integer. You want to store everything as strings. So we have modified the coordinate, but we have not actually written it into the file yet. So let's do that. We don't want to overwrite our existing file. So instead we save a new file. So we take our old file name, we give it a little extension, and then we're ready to save our XML data to this new file name. And the way we do it is by simply taking our tree variable and we use the write function to our new file path. So when we did this up here, we changed the coordinate, we changed our tree. So now our tree variable has changed and we can just save it back to a new XML file. So let's try to run this piece of code. If I now go back into my folder here, you can see I get the file here. And if we compare these two, you can see we have a 1 here, and in this file we had a 0. So we have successfully modified our XML file. And I know that this is maybe not a very exciting change we have done. It's not a very useful change. So let's have a look at a practical example to see how we can potentially use this that we have learned here. So let's say you want to do a robustness analysis. You want to check what happens if we lose a column. So you want to run through your model and you want to remove one column until you have checked the building without all the columns, let's say just in the ground floor maybe. And rather than sitting and doing this manually, you can just take your XML file, loop through it several times and remove one column, save the file. Remove another column, save the file. So let's look at how we can do that. And rather than running it in little individual cells, I've just gathered the entire script in one cell here. So we start by finding our file. We define a folder where we want to save our output files in. Then we check if the file exists. We make our output folder. And now we're ready to load the XML. So this here you saw before. We load the XML into the tree. We get the root. And now we try to find all entities. And then we have a nice bit of list comprehension going on here. Let's start by looking at this statement here. We take our entities and we find all bars. So for every bar in entities, but only if bar is of bar type column, then we take bar and get the name, and then we get a list out with all our column names. So in short, we are looping through all our entities and we're checking that if the type is column, we add the column's name to a list. So now we have the names of all columns in the building and we're going to start looping over them. So for every column name, we want to create a new model that does not contain that very column name. So we loop over the column names. And the first thing we do is to create a copy of our XML file. We don't want to edit the original one. We want to create a new one every time. So we create a tree copy, a root copy, and we find all our entities. Then we go into our entities and we find all bars. And then we say that if our bar has column name, then we remove it. And when we have removed it, there is no need to be inside this loop anymore. So we can break this loop here, which means we get back out here and we can save the file. So let's try and run this script here. So we click here, And now we have created the folder robustness checks. We have that here. And you can see in here, we have a series of XML files with each of the columns removed. So now we can load these into FemDesign, run each model, and check how it behaves. So let's try another example as well. Let's try to change our slab thickness. Let's do a sensitivity analysis. What happens in our building if we change the thickness of all slabs by 10% plus or 10% minus? So we do the same thing here, read the file, then we define a function here. I'm going to get back to that one. And then we say we reduce the slab thickness by calling this function here, and we increase the slab thickness again by calling this function here. So let's see what this function does. First, we load a fresh copy of the XML tree. Then we go in through our entities. We go deeper and we look for slabs. Then we look for a thickness. Then we get the value of the thickness. And then we have our thickness defined in this variable here. We multiply it by a factor, which in this case is 0.9. Our next function call is 1.1. Then we convert it to a string, very importantly, take our element and set the thickness to this new value. And we can then save the file, and we have created a new XML file with a reduced slab thickness. So let's try to run this script. You can see now we have a folder, thickness variations. We can go in here, robustness, thickness variations, and we have our two new XML files here. I hope you have enjoyed this video. If you have any questions, just leave a comment below. And if you're interested in learning how you can use Python in structural engineering, you can go to my webpage, pythonforstructuralengineers.com, and sign up for my course.